I work with IIT-Bombay as a scientist. Today I'll be talking about WLAN Interworking with 5G. So this is the agenda for today. I will briefly touch upon 5G requirements and use cases and certain trends of the mobile networks. Then I will briefly touch upon Wi-Fi technology capabilities and also about the Wi-Fi deployments today, specifically the public Wi-Fi networks. And then we will look at Wi-Fi and the synergy between 5G use cases. And at the end, we will talk about interworking of Wi-Fi with 5G network. The last part is the core of the presentation, and I will be spending more time on this part. 5G system is the next generation of mobile communication system. It is formally called IMT 2020. It has been defined by ITU. It provides much enhanced capabilities over 4G, the earlier IMT advanced system. On the right hand side, you can see the different capabilities provided by IMT advanced for 4G vis-a-vis IMT 2020 or 5G. And you can observe that in most of the parameters, 5G is providing much advanced capabilities over 4G. Some of the key scenarios that the 5G is expected to support is called enhanced mobile broadband, which will support devices with high-speed mobility up to 500 kilometers per hour. Then it will also provide very high peak data rates up to 20 Gbps, and it supports very high spectral efficiency, 30 bits per second per hertz. The other scenario is massive machine-to-machine communication, which basically deals with a large number of machines communicating with each other, and this is also known as massive Internet of Things. It is expected to support a very large number of devices in a small area, say up to the tune of 10 to the power 6 per square kilometer. And then another use case which is quite important is called ultra reliable low latency communication, URLLC, which basically has been developed to support extremely low latency applications, such as medical surgery or some of these applications, or mission critical communication. Some of these, we will see some of the examples of these applications later. But these are, the ultra reliable low latency communication is one of the really important use case of 5G. In this slide, we see some of the use cases of these three types, which are expected to be supported in 5G. You can see, the work and play in cloud, or augmented reality, or industrial and vehicular automation, or self-driving car, or mission-critical broadband communication. Similarly, sensor networks and smart cities, and also voice call, and so on. So these are some of the applications or use cases which are expected to be supported by 5G. You can see that they are basically falling into these three categories. Many of them are actually not in one or the other, they are probably requiring both. So the augmented reality may require low latency as well high speed data access. So all these three the three scenarios give rise to a lot of applications and use cases which are expected to be supported by 5G. You can observe that 5G is expected to support a huge diversity of applications. So it is not like the earlier, first generation or second generation mobile networks where voice was the only application which was supported by mobile networks. 5G is expected to support all types of applications, and the diversity of applications is going to be immense. Now, we will look at certain trends of the 5G and in general of the mobile networks, how it is changing or evolving. A massive IoT or massive machine-to-machine communication is one of the key use cases of 5G. This use case is essentially fueled by applications like smart homes, smart cities, or increased automation, and so on. Now, interestingly, most of the IoT devices use wireless connectivity, say Wi-Fi, Bluetooth, 4G, and 5G. Once the 5G is getting deployed, but most of these devices are stationary. So what we see today is that mobility is not so important anymore. Mobile networks are being used increasingly for flexibility, ease of use, and so on, not necessarily to support mobility, communication while a person is mobile. So even the large number of smartphone users or normal mobile broadband application users are stationary while they are using mobile network. So we might be sitting at home and accessing the mobile network to say use social media applications or use video download or watch the IPL cricket matches and so on. So originally, mobile networks were created to primarily handle mobility. However, it's not so important anymore. The other important aspect or the trend which is there is or the requirement you can say, is the need to reduce cost and resource consumption as we use mobile networks more and more. Now let us look at quickly at the Wi-Fi technology and some of the capabilities it offers. So there are multiple Wi-Fi technologies which are available in the market. So we have sub-gigahertz Wi-Fi 802.11ah or Wi-Fi Halo, which can support up to 40 Mbps data rate. It supports relatively long range communication, and it can, this is one of the important technologies in use. And then obviously Wi-Fi 5 and 6, 2.4 and 5 gigahertz, 802.11ac and 802.11ax, which support quite high data rates. And then Wi-Fi 6E, which is extension of 6 into 6 gigahertz band, where almost 1200 megahertz frequency bandwidth is available, and the data rate can be much higher in 802.ax in 6 gigahertz. And then we also have millimeter Wi-Fi, which is 60 gigahertz, 802.11ad and 802.11ay. Now, Wi-Fi deployments are increasingly being used by mobile users. Most of the major economies, 50 to 70% of total usage time is on Wi-Fi networks. In India, it is much less, but it is increasing very quickly and at a very fast rate. Public Wi-Fi hotspots are, in the developed world, there are a large number of public Wi-Fi hotspots. It is expected that there will be some 600 plus million Wi-Fi hotspots in 2023. And the situation in India is not so great, but it is increasing at a very rapid rate. National Digital Communication Policy 2018 also emphasizes on the deployment of Wi-Fi hotspots. It is assumed that it is understood that Wi-Fi hotspots will be one of the key mechanisms for broadband proliferation. However, one of the key issues in Wi-Fi networks or public Wi-Fi networks is authentication and security. Now, the 5G and Wi-Fi, what is the synergy between the two? So Wi-Fi is a very cost-effective technology, and we think that it can be a very important access technology for 5G. Wi-Fi can support a large number of eMBB use cases like hotspots, internet access, work in cloud, online classroom, HD video, conferencing, virtual reality, social networking. All these applications can very easily be and very well be supported over Wi-Fi networks. We can use Wi-Fi 5, 6, 6E or mmWave Wi-Fi, all these technologies for usage of supporting eMBB use cases. Similarly, the IoT use cases can also be very well supported by Wi-Fi. Smart homes, smart cities, and all these technologies, sub-gig Wi-Fi and Wi-Fi 5, 6, 6E, all of them can be used to support IoT use cases. So we see a lot of synergy between Wi-Fi and 5G use cases. And we think that 5G is increasingly going to use Wi-Fi as one of the access technologies. Now, how does the 5G system architecture look like? So this diagram shows the 3GPP defined system architecture of 5G networks. You can observe here that there is a unified core network called 5G core with a separate control plane and data plane using the STM technology. And unified core supports multiple access technologies in a unified manner. So we can have 5G NR, new radio access technology, or even LTE radio access technology, or Wi-Fi, or other technologies as well, connecting to the 5G core in a unified and integrated manner. The interface between the access network and the core network is common. So there is no difference between the interface which is used by Wi-Fi access technology to talk to the core network and the 5G NR technology talking to the core network. So they both talk using the same access, same interface towards the core network. And as we can see, it's a multi-rat network with the presence of multi-rat access, multiple rats in the access network. And we think that there will be a large number of base stations, with small coverage areas. Those base stations can be 5G NR millimeter wave based base stations, or Wi-Fi base stations, or access points, and so on. Now, if we look at this architecture in detail, here are some of the interfaces which have been shown. So the three nodes at the top right-hand corner, the AMF, SMF, and UPF are nodes of the core network. AMF, SMF are basically the control plane nodes, and UPF is the data plane node. UE can connect to the 5G core either through non-3GPP access like Wi-Fi access, or it can use 3GPP access like 5G NR, radio access technology, to connect to the 5G core. Now, when it uses whether it uses 3GPP access or it uses Wi-Fi access, non-3GPP access, the communication between UE and core remains the same. So you can see that the N1 interface, which is between the UE and the AMF, is the same irrespective of the access technology being used by the UE. And similarly, the Wi-Fi access and the 3GPP access, they both use same interface to talk to the core. So in order to enable Wi-Fi access technology to talk to the core, an interworking function N3IWF has been defined by 3GPP, which basically is the interworking point between the Wi-Fi access technology and the 5G core. Now, this interworking function supports the same N2 interface, or the control interface between AMF, which is also used by the 3GPP access or the 5G NR radio access technology. So you can see that the 5G NR access also uses N2 interface to talk to AMF, just like the N3IWF interface. Similarly, the data plane of core, which is the UPF function, also talks to the non-3GPP interworking function and 3GPP access function like GNB over the same interface called N3. So you can see that there is no difference between how N3IWF talks to core and how the 3GPP access GNB talks to. They both talk to the 5G core in the same manner. Now, because of this common and unified core, we can have enhanced 5G core-based authentication and secure communication over Wi-Fi for a UE. So a UE can use the 5G provided authentication and security while it is using the Wi-Fi access technology, which is a very important point in the integration of Wi-Fi with 5G technology. Now we can quickly look at the architecture, protocol architecture of Wi-Fi access and 3GPP access, and we can see the common points there. So we can see that on the left hand side corner is the 3GPP access stack zone, and then on the right hand side on the bottom corner the Wi-Fi access stack has been shown. So we can see that the NAS layer which is used in the UE is common whether it is using the 3GPP access or it is using the Wi-Fi access. The Wi-Fi access node N3IWF uses the same N2 stack to talk to AMF as used by 5G AN or 5G access network or the GNB. Similarly, the AMF, irrespective of the access technology, it uses the same N2 stack to talk to N3IWF and also the GNB. Now, if you look at the data plane bit of Wi-Fi and access, how the data is exchanged over Wi-Fi access and what protocol stacks are used, and if we look at the data plane of 5G NR based access technology, so we can see that the UE has the same PDU layer irrespective of the access technology being used. Similarly, the 5G AN node, which is the GNB node, uses the same GTPU, UDP, IP, L2, L1 stack to talk to the 5G core, that is UPF, as the N3IWF in the Wi-Fi interworking. So the N3 stack on the N3IWF is the same as the N3 stack on the 5G access network node, that is GNB. So we can see that there are a lot of commonalities across interfaces while talking to the 5G core, both on the UE side as well as on the access network node side, like N3IWF for Wi-Fi and 5G GNB for 5G. Now this is a high-level call flow of Wi-Fi access when the UE is accessing Wi-Fi 5G network through Wi-Fi. So the initially UE associates with the 5G core through Wi-Fi AP and through the N3IWF, and then it connects to the AMF, SMF, and exchanges NAS messages. So initial association is with Wi-Fi access point, that then it can have communication with N3IWF, and then after it connects to the N3IWF, then it can exchange NAS messages with the core, and then it can establish PDU session via the core and through the Wi-Fi AP and N3IWF, and then exchange finally data through Wi-Fi access point and N3IWF, and then UPF. Now let us look at a very high level view of the 5G NRAN architecture. So the NRAN comprises of a node called GNB. GNB is basically not a single node. It has two parts to it. One part is called the GNB centralized unit, which is responsible for talking to the core and centralizing all access traffic through to the core. And then it has multiple distributed units. The distributed units are basically responsible for providing radio and physical layer connectivity to the UEs over Wi-Fi radio access. Now, in a single GNB can have multiple GNB duos, but a single single GNBCU. So as shown here, on the right hand side, you can see there is a single GNBCU control plane entity, and then it has multiple GNBCU user plane and a large number of GNBDUs. If we look at the Wi-Fi access and look at the 5GNR access architecture, we see a lot of parallels there. In the case of GNB, there is a GNBCU, a centralized unit, which is responsible for talking to the core, both for the data plane as well as the control plane. Whereas in the case of Wi-Fi access, this centralization is happening at N3IWF, which is again similar to the GNBCU, is responsible for talking to the 5G core control plane as well as data plane. Now, multiple Wi-Fi access points can be connected to N3IWF, and these Wi-Fi access points are basically responsible for providing Wi-Fi access to mobile devices. So just as a large number of GNBDUs can connect to one GNBCU, multiple Wi-Fi access points can be connected to a single N3IWF, and they all can provide connectivity to UEs. Now, this architecture also supports multi-access, which means that a mobile device can simultaneously connect to N3IWF and Wi-Fi and GNB. So it can use both access technologies, and it can connect to 5G core over both these technologies, access technologies simultaneously. This concurrent access to multiple RATs provide improved connectivity and better traffic steering, switching, and splitting across these two RATs. And the UE can, depending on the availability of each of these RATs, it can decide to use one or the other or both of them simultaneously. So just to summarize, Wi-Fi and 5G, we think that there is a large amount of synergy between the two. Wi-Fi can support many 5G use cases. It also supports multi-access capability, which allows a UE to connect simultaneously to 5G access technology like New Radio and Wi-Fi technology, and transfer data over both of them. With integration of Wi-Fi and 5G, the authentication and security aspects of Wi-Fi networks improve. You can use the authentication services provided by 5G core, and the security has also been improved through the integration of IP security between UE and N3IWF. So, and the next point, third point, is that it is a cost-effective solution. Wi-Fi is a very cost-effective technology. A large number of Wi-Fi devices are already available and are being deployed every day, and we don't really need to develop any Wi-Fi access points. Only the N3IWF needs to be developed, which can be, a software-based solution. No specialized hardware is needed for N3IWF, so it is easy to develop and it can easily be deployed in cloud. So we think Wi-Fi and 5G has a lot of synergy with each other, and going forward we will see a lot of deployments of Wi-Fi in the 5G network. Thank you very much, and that's about it. If you have any questions, please let me know.